Here we go. Again, you had three boxes that look a heck of a lot like they looked like the last couple of days. Show me that you learn how to do this stuff, please. That'd be great. Get two or three of these boxes right here correct, and that is your goal. All right, next week, I'm aiming for Wednesday. Next week is the big fat Unit 5 test. The good thing is it's only assessing you on two Common Core standards. Do you know how to divide numbers that have two digits by one or two digits? Do you know how to solve division problems with decimals? Those are the two things it's going to test you on. And if you're like, yeah, I can do both of those, then you're fine. Then you're going to be great. You're going to do very well. All right, so we are on page 233 in your books. Please open your book to 233 and work with me. We're going to jump around a little bit. We will do all of 1 through 5 together, and then we'll only do the evens after that. And then in the live session, we'll fill in the gaps. And then with homework, we will finish it off. It occurred to me that yesterday I never gave you the homework I told you I was going to give you. So maybe we should have double homework today. Well, we'll make that determination later. It says, select the expression that involves a shift in the digits 2 places to the right. So let's talk about what they're really saying here. So here's a number. Here's a decimal. It's saying that the digits, so let's just call them 1 and 2, they're going to go 2 places to the right. Now, it's saying the way that you and I have been talking about it, we've been talking about moving the decimal instead of the digits. So the decimal would move 2 spots to the left. So what operation would cause a number to change like this or like this, depending on how you're looking at it? Which one would it be? A, B, or C? The correct answer is B, because when you have 30 and you're divided by 10 to the second power, you have your decimal and you move it over once, twice. So therefore, it turns into 0.30. Okay? So the decimal, or the decimal moves 2 spots left, or you could look at it like the digits themselves jumped backwards twice. All right, classify each answer, which a quotient is the answer to a division problem, as being equal to 52, 5 and 2/10, or 52 hundredths. Write the letter in the correct box, okay? So why don't you pause it for a second and try to get this one correct. So A would be divided by 10 to the second power. So your box you would choose is right here. Right here. You put A in because it turns into 0.52. So take a second and try to fit B, C, D, E, and F. Okay. If you're ready to see the real answer, you can unpause, watch. Here we go. B, 52 divided by 10 to the first. Decimal moves over once, it's 5.2. What about C? Well, divided by 10 to the first power, remember 520 has an invisible decimal after it. It's going to move over once, it's going to turn into 52. What about 520? Well, it has an invisible decimal here. Divided by 10 to the second power means 1, 2. Answer is 5.2. And then 520 divided by 10 to the third. There's the decimal. It's going to move over once, twice, 3 times. So it turns into just 52 hundredths. And then F, you're assuming right here, correct? Well, let's see. Here it is. Moves left once, twice, 3 times turns into 5.2. So it actually goes in that box. So those are your answers. Number 3, it says explain why 3 and 6/10 divided by 400 is the same thing as 360 divided by 4. Let me just show you guys here because I don't know if I've ever really done a good enough job of explaining it. Isn't 360 divided by 4 the same as an improper fraction like that? Hopefully you're saying, yeah, yes, it totally is, because in order to find that answer, you would pull out as many 4s as you can, just like you do with 360 divided by 4. So therefore, I guess it'd be easier if I put it this way. 0.04 over 3.6 is also a fraction, because you're trying to see how many 400ths is in 3 and 6/10. So we could easily say, as long as you do the same thing to the bottom and the top, they're going to be equal. And check it out. Moving the decimal over twice is getting it multiplied by 10 to the second power, which is 100. So if you multiply the bottom by 100, and you multiply the top by 100, 1, 2, it turns into 360. So this would be a perfect answer for number 3. If you literally just show that they're equivalent fractions. And then while you're doing that, I'll just explain with division for this exact reason, whatever you do to one side with the decimal, moving the decimal over, as long as you do the exact same thing to the other side, then the answer will not change. The answer will be the same. And this is important because it is so hard to count by 400ths, but it's very easy to count by 4. So that's why our first step is always get rid of that decimal. Number 4, why does dividing 5 by a decimal smaller than 1 give the answer that's greater than 5? Well, because you are, so in division, both parts have very different jobs. Okay? In division, both parts have very different jobs. The first part is called your dividend. It goes on the inside. It tells you what you're starting with. The second part is called your divisor. It goes on the outside, and it tells you what it takes to make a group. Okay. Now, if this number is always bigger than 1, then it's very much easier to look at it like these people are splitting this. How much is each person getting? But if it's smaller than 1, it's, in my opinion, a lot easier to look at it like this is all it takes to make a group. So let's just pretend it's 0.5. Why is that answer bigger? Because you have 5, and all you need is 0.5 to make a group, right? That's all you need. So whenever this is smaller than 1, each of these can make more than one group. And if each of these can make more than one group, then this answer will be bigger than what you started with. Okay? All right. So whenever you're dividing by a number smaller than 1, now that's not this number, that's this number, your answer is going to be bigger than the number you started with because each of these can make at least one group, but more than one group. Okay? So it takes less than 1 to make a group, so each whole will make more than one group. I don't know why I put an S there, but more than one group. Let's go on to number 5. A farmer ships 4 times as many oranges as tangerines. The farmer ships 8,260 oranges, so how many tangerines did he ship? So it wants us to both write an equation and solve. And what I would suggest Whenever you have any problem like this, write the equation first to make sense, okay? So the farmer ships 4 times as many oranges as tangerines. So which one would be more, the oranges or the tangerines? A farmer ships 4 times as many oranges as tangerines. 4 times as many oranges. So more oranges, correct? So what I'm seeing is tangerines multiply by 4 equal oranges. And we know what oranges are, 8,260. Now, a lot of people can just see that formula and they know exactly how to find the answer. That's not everybody, though. So what I always tell people is put in a random answer, like put it in a random, we call them fact families, like 2 times 3 equals 6. It's random, right? But it's easy. My brain could look at that and say, oh my gosh, that's easy. What I'm going to do is I'm going to use this to figure out how to find the answer. So the one I don't have is this one. So how could I go from 6 to 3 to 2? You divide. I'm going to take 6, divide it by 3, and that's going to equal 2. So if that works with my made up easy one, that's exactly what I'm going to have to do for this hard one, the real one. So I take 8,260 and I divide it by 4. And then I ask myself, how many 4s go into 8? Well, 2. What's left over? Nothing. How many 4s go into 2? None. What's left over? The whole thing. Bring down the next number. How many 4s go into 26? Well, I know 5 times 4 is 20. Ooh, 6 times 4 is 24, so it's 6. Two's left. And how many 4s go into 20? 5. Anything more? Nope. So how many tangerines did we have? 2,600 and, I'm sorry, 2,065. Okay. Let's look at number 6. So we'll just do the evens here. I'll work for about 10 more minutes and then we'll meet at 10:30. Jamal buys postcards, Washington, D.C. for $10.20. That doesn't include tax, but we're not worried about tax. Each postcard cost 85 cents. How many postcards did our buddy Jamal buy? Try this one out. What I'm going to do here, I'm going to take my 1020. It is 1020, right? I can't see. Hold on. Yep. I'm going to take my 1020. And I'm going to divide it by 85 cents. Why am I doing that? Because I have 1020. I want to figure out how many 85 cents are in 1020, right? We know our answer is going to be bigger than 10 because we're dividing by a number smaller than 1. So every dollar will be able to buy more than 1, kind of. So am I allowed to have this decimal? No, sirree, Bobarooski, so I have to get rid of the decimal. In order to get rid of the decimal, I had to move it over 2 spots, so I have to do the same thing here, which actually, luckily, gets rid of the decimal totally. So how many 85s are in 102? 1. What's left over after you pulled out the 85s from 102? Well, we have 12, and then this turns into a 9. 12 minus 5 is 7. 9 minus 8 is 1. Bring down this number. How many 85s go into, well, 170? 2. Let's see what 85 times 2 is. 5 times 2 is 10. 16, 17, check that out. It's exactly 170. So how many postcards did I buy? 12. Okay. 12. Let's go down to number 8. Mr. Adams divides 223 markers. 223 markers. He divides them equally with 26 students. And then any extra marker that he has, he just throws in a box. My question is, what is the least number of markers he puts in the box? The least. Well, let's try to make sense out of this. Any leftover he puts in. So we're just looking for the remainder, correct? What is the smallest remainder? Well, I don't really understand that question, to be completely honest. I think they're saying if he gives out all of the markers that he can, what's the remainder left? So that's the way I'm going to take it. So I'm going to kind of ignore the least. Just say he's going to divide up all these markers with 26 students. Whatever's left over, he's put in a box. What's going to be left over? So we're just going to divide, and we're going to stare at the remainder. We want to see the remainder here. 2, 2, 3. 26. First thing it's going to go into is the whole thing. 26 times 10 is 260. Too big. What about 9? I think that might still be too big, but there's only one way to find out. What would 9 groups of 26 be? Well, 6 times 9 is 54. And remember, obviously here, you can use whatever technique you like better. A lot of people still like just using lattice, even though it's by 1 digit. That's cool. 18, 19, 20, 21, 22, 23. Too big. So instead, let's do 26 times 8. Some of you guys understand that you could just subtract 26 from this. Since this is 9 26, if you subtract 26, you'll get 8 26. 6 times 8. 8 times 2. 208. That was 8 groups. So everyone gets 8 markers. How nice. Now we got to figure out what's left over. When I take 8 from 3, it's illegal, so I have to borrow. 13 minus 8 is 5. 1 minus nothing is 1. There's 15 left over. 15 markers left over. So what is the smallest amount? The answer is 15. 15 is your answer right there. Looks like I have time for maybe 2 more. Number 10, solve. Express the remainder as a whole number, show your work, draw a model to show how you solve the problem. Well, I'm not worried about drawing a model. Let's just solve the old problem. You know what I'm going to do? I'm going to cut the lesson short. We're going to stop it at 10 today. This gives you enough time to slow down and try this question. So try number 10 your best. Try your best on number 10. Let's see what the answer is, shall we? How many 57s are in 97? 1. What's left over? 40. I count by 50s. 50, 100. 150, 200. 250, 300. 350, 400. 8 is 400. But I counted by 50. So I actually have more than 50. So there's no way it's going to be 8. So my guess is 7. And remember, it's not important that you guess correctly. It's important that you understand how to check your guess. So I'm going to check what 57 sevens is. 7 times 7 is 49. 7 times 5 is 35. 36, 37, 38, 39. Whew. Yeah, that's a perfect guess. So the answer is 17 with a remainder of 1. Your book, for some reason, is asking us to put the remainder as a whole number, but I like putting it as a fraction. So how many groups do you get? You get 17, and you have 157ths left, or 17 remainder 1, depending on how you did it. So I'm going to stop there, and depending on how our 10:30 meeting goes, maybe we will just do the second half next week instead of rushing through it. All right. Well done. If we go with an animal today, let's go lion. Okay? I'm not lying. Let's go lion. See you at 10:30.